Alright, now let's look to how we're going to deal with these decimal numbers. I've got that a little bit neater at this point. Let's go. Now you're going to find this extremely easy, and it is. Always think of your table. Your table could be on your mind, but I'm just going to show this table up here for you. Where's 13? There's 9, so 10, 11, 12, 13. So how do we represent binary as a hex? Well, 13 is represented as, if I can get back in here, the letter, I can't get back in there, can I get, yeah, D. So my hex number is hex equals D. And we don't need to do that, I beg your pardon. It's not a text string, it's simply representing our conversion from binary to hexadecimal. But we're going to try a bigger number now. Well, the first thing to do is, when you get a number that's greater than 4, is to group them into 4s. And here we go. I've spaced it out so it's easy to see. And we've got, 1, 2, 3, 4. And I believe that's grouping. Let's just see if that's worked. No, it hasn't. Let's just group that again in another color. Sorry about that. So 1, 2, 3, 4. And 1, 2, 3, 4. And we've got this little guy left over there. Whoops. So 2 groupings of 4 with a 1, and that 1 is on its own. Let's look at the first 4 digits of this number and work out the decimal value. We should be able to do this in our heads by now. We've got 8, we've got 4, we've got nothing and nothing. So 8 plus 4 is 12. I'm going to put a 12 under there. And in hexadecimal, how do we represent this 12? We represent it, let me see, let's go back to our table. So we've got 9, 10, 11, 12. It's the letter C. So I'm going to say 12 equals C. Let's look at 0101. And we've got 8, 4, 2, 1. So, sorry, no 8 and 4, no 2, and 1. Sorry, I said earlier 8, no 8, 4, no 2, and a 1. So we've got 5. And 5 is itself in our hexadecimal value. So that's easy enough, so we don't need to say any special representation there. The 1 is all on its own, so we're just going to put a 1. So in hexadecimal, this number, this binary number, is represented by 1, 5, C. Can you see how you would break this back into binary? If I gave you 1, 5, C and said convert back to binary, you would work from the right-hand side and you would say, oh, the C is 12. How do I represent 12 as binary? The 5 is the next grouping of 4. How do I represent 5 as binary? And this is a 1. How do I represent that? Oh, that's the last grouping, but it's not 4. It's a 1 on its own, so it must be 1. And hopefully you'll see that converting binary to hex and hex to binary is not that difficult at all.